Okay, so now we're going to talk a little bit more, go a little more in depth with the idea of functions. First of all, so far we've had something like this. I don't know, y equals x plus 3. In earlier videos we did problems where we graph this, yeah, y equals mx plus b. But this is a function. Why? Well, notice for every x value that I plug in, only one y value comes out, yeah? Let's say x is 5, yeah? When I plug in 5, what is y? It's 5 plus 3, which is 8. So when x is 5, I only get one y value, and the y value is 8, yeah? So for every x value, I only get one y value. That is a function, yeah? So let's go. So what's the idea here? The idea of a function is the x value is what you put in, and when you put that in, the y value comes out. So we say the y value is the dependent variable, x is the independent. Why? Well, like I was just saying, I pick an x value. That's what I put in to my function. If x is 5, what comes out is y is 5 plus 3, which is 8. In other words, the value of y depends on the value of x that we pick. Yeah? If I pick a different x value, if x is 10, well, now y is 13. The value of y depends on the value of x. That's why y is the dependent variable. X is independent because it can be anything it wants. It's independent. Yeah. All right. So that's the idea. X is the input. Y is the output. Now, instead of y, we start using this notation. F of x. That's the same thing. In other words, what I'm saying is y is equal to f of x. So these are really the same equation. We're just writing it a little different. This is function notation. Why would we use that? There's a couple reasons. One, think about your air conditioning bill. All right, your air conditioning depends on the temperature, the average temperature outside, yeah, for the month. If it's a really hot month, you have a high cooling bill, air conditioning bill. In other words, the cooling bill is a function of the temperature. The cooling bill depends on the temperature. Here, the value of my function, that's y, the value of my function depends on the x value that I pick, yeah? This just makes more sense. We don't always want to just write f of x. Cooling bill depends on the temperature. All right, there's another reason we use this notation. Let's say I said x equals x plus 3, y equals x plus 3, and y equals x minus 10. And I said, all right, what is y equal to when x is 20? Well, you don't know. If I plug in 20 here, I get 23. If I plug in 20 here, I get 10. The question is which one do I plug it in? We don't know. It's ambiguous. But if we write this, let's say this is f of x, and this is g of x. Well, now I can say, what is f equal to when x is 20? Clearly it's 23. What is g equal to when x is 20? Well, g is 10. Now it becomes much clearer which function, f or g, do I plug it into. So these are some of the reasons we have this notation. So the next video we'll just do another example of determining if a situation represents a function.